this video, you will learn how to simplify radical expressions. Look at this theory first. For any non-negative real numbers a and b, the square root of ab is equal to the square root of a times the square root of b. Look here. It says here the square root of ab is equal to the square root of a times the square root of b. If a is greater than or equal to 0 and b is greater than or equal to 0. So that means if a and b are non-negative integers and they are multiplied here, the square root of this number would equal to the square root of a times the square root of b. And here it's in numbers. Square root of 4 times 9 is equal to the square root of 36, or 6. There is another way to do this for more complicated problems, however. For example, the square root of 4 times 9 is equal to the square root of 4 times the square root of 9, which is equal to 2 times 3, or 6. Let's do a few examples. 4 times the square root of 66 times g squared times h to the 4th power. So let's break this down. Prime factorization. The square root of 66 is equal to 11 times 6, which is 2 times 3, and then obviously g squared, and then h to the 4th power. And of course, all of that is multiplied by 4. Okay, so let's see what we can bring to the other side, or make it simplified pretty much. We can circle the h, we can circle the g's, and it doesn't look like we can circle anything much else. So we're going to bring this over. So it's going to be 4 times g times h squared, because remember there were two sets of these. So 4 times g times h squared times the square root of 11 times 2 times 3, which is 66. And that is the simplified expression for this problem. Let's try another one. The square root of 4c to the third d to the third times the square root of 8c to the third d. Okay, so since we're multiplying, let's just spread this all out. So 4 is equal to 2 times 2, then c times c times c times d times d times d. Now let's combine it with this because they're both square roots anyway. Okay, so 8 is equal to 2 times 2 times 2. Then there's c times c times c, and then 1d. Alright, so let's see what we can do here. I can definitely circle the 2's here. I can circle the c. I can circle the d's here, the 2's here, the c's here. And we're left here with c, d, 2c, d. Now, obviously, I can take the c's here, and I can take the d's here, and we're left with 2. So now let's take all these sets and combine them and move them over to the other side. So it's going to be 2 times 2 is 4. Then we have 3 sets of c's, so c to the third power, c to the third power. Then we have 2 sets of d's, so d to the second power. And we have a remainder of 2 left, the square root of 2. So it's going to be 4 c to the third d squared times the square root of 2. Let's try a harder one. Which expression is equivalent to the square root of 45 divided by 10? Alright, so this is a little bit tricky because it's division, but one thing you should know is that when we have a fraction here, this is literally just equal to the square root of 45 divided by the square root of 10. So maybe that makes it a little bit easier. We'll simplify it. The square root of 45 is equal to 9 times 5 And then 10 is 2 times 5. So 9, the square root of 9 is 3, so we can bring that over here. So it's going to be 3 root 5 over root 10 again, but we'll keep it like this. Now, look here. The square root of 2 times the square root of 5. And up here, we have 3 times the square root of 5. Notice we can cross these out, and we're left with 3 over root 2. Now, we have to bring this square root up here. And to do that, we must multiply both the denominator and the numerator by the square root of 2 to eliminate the root at the bottom. And now, once we eliminate that, here, 2, the square root of 2 times the square root of 2 is equal to 2 because it's 2 squared, right? And now we're left with 3 times the square root of 2. So our final answer would be 3 root 2 divided by 2. And that is right here, letter D. Let's try another example. Here's a word problem. Starting from a stationary position, the velocity v of a roller coaster in feet per second at the bottom of a hill can be approximated by v is equal to the square root of 64h, where h is the height of the hill in feet. A. Simplify the equation, and B. Determine the velocity of a roller coaster at the bottom of a 134-foot hill. So first, let's do A. Let's simplify the equation. So we're given v is equal to root 64h. All right, so let's see. What is equal to 64? Well, 8 times 8 is equal to 64, right? And that's a perfect square root. And that's times h. And that is equal to v. So, what we can do here, we can circle this, we can bring this over here. So, our velocity is equal to 8 times the square root of h. Now, that's our simplified version. Now it says determine the velocity of a roller coaster at the bottom of a 134-foot hill. To do this, we will need a calculator because, well, it's faster. So let's do it. The square root of 134, because again, we're subbing for the height, the bottom of a 134-foot hill. So we're going to sub h for 134 feet. So square root of 134 is equal to 11.57. So we have to multiply that times 8 to reach our velocity. So we're going to do 11.57 times 8. And we get 92.56. So we're going to write that this is our velocity. And don't forget to put a label in feet per second. And there you go. That is simplifying radical expressions. Oh, and just so you know, I've included a bunch of links in the description below so that you can practice whenever you need to. It's not my links, they're not what I created, but there are some really good websites like Khan Academy and some really good games and stuff that you can use to practice. Hope you like it. Bye.